I'll be continuing this 1988 AP Calc AB multiple choice part of the exam. We left off on number 27, so let's dive right in. X is 3, function given by this guy is, well, it's for sure defined because x can equal 3, so that's not A. Is it continuous differentiable? Well, first of all, something's differentiable, it's automatically continuous. So this cannot be true, just by the definition. Okay, now, what about this other three? So we basically have to find out if it's continuous or if it's differentiable. So, and if it's differentiable. So limit x goes from 3 to the left of f of x. What is that? As we approach from the left, it would be 3 squared, which is 9. Hopefully that's visible. How about when we approach from the right? It would be what? 6 times 3, which is 18, minus 9, which is equal to 9. So it's continuous. Okay, so we can eliminate that one. Okay. By the way, it's continuous because limit from the left equals limit from the right. So limit as x goes to 3 is equal to 9, which is equal to f of 3. Okay? So it's continuous. Is it differentiable though? So I'm not going to write the whole limit notation out for the derivative, but because derivative, remember, is limit as h goes to 0. So we can approach from, or there's a different definition where, let me just write it out. Okay, this is also the derivative. This is f prime of 3. So we can approach 3 from the left or 3 from the right also. So from the left-hand side, it would still be this. It'll be what's derivative of x squared? That's 2x. We evaluate x is equal to 3. That's equal to 6. How about the right-hand side? That is derivative of this guy is just 6. Okay? So it's differentiable also. So 27 should be E. Okay? And only 53% of the people got that right. The second most popular choice was B, continuous but not differentiable, okay? So they probably got this continuity part right, so hopefully this part is more straightforward. Differentiable, it has to be differentiable from the left and from the right also, because remember the limit definition of the derivative. Okay, this one probably people fell for, and we'll go from 1 to 4, absolute value of x minus 3. Remember how absolute value looks? Looks something like this. Okay? This is this guy. It's just a sketch. So when it's between 1 and 3, it's on the negative side. The opposite of x minus 3. When it's between 3 and 4, it'll be on x minus 3. So we have to write this integral as, let me do it on a piece of scratch paper. I'm going to go from 1 to 3 of negative of x minus 3, which is 3 minus x. dx plus integral from 3 to 4 of x minus 3 dx. So we could do all that out, or since we know how the graph looks, let me redraw it here. This is 3, right? 1 and 4. We can add these triangles. That's maybe even easier. Okay, so when x is 1, what's the value? It would be 2 over here, right? This guy would be 2. So let's draw a triangle. We need this area, and we need when x is 4, the value is 1. So this guy is 1. So this is not a good sketch. So 4 would be over here more like. Okay, so this is 1. So this is the triangle here. So it'll be half the base here, which is 2. The height is 2 plus half. Base here is 1. The height here is 1. So this is what? Is equal to, that is 4 divided by 2, which is 2, plus half, 2.5. So it should be, 28 should be C, yes. So that's another way to do it. Okay, instead of doing the two definite integrals by fundamental theorem calculus, since we know what absolute value of x minus 3 looks like, you should just sum up the area of the two triangles. That's easier. Okay, so this was only 34% correct. Most people picked this one. I'm assuming it's because they didn't break it up. Okay, I'm not going to do it out, but work it out like that, but okay. That the key point was this changes sign. Okay, limit as h goes to 0, tangent 3x plus h minus tangent of 3x over h. Okay, this looks like derivative. Okay, so this is the other definition that you might be more familiar with. Limit as h goes to 0, f of x plus h minus f of x over h. Okay, this looks exactly like that. So this is just the derivative of tangent 3x, which is secant squared of 3x times 3 by the chain rule. So it should be B. 45% of people got this right. Okay, 21% picked this one, and I have no idea how they would have picked that. But anyway, derivative is the point. Region in the first quadrant is enclosed by the graph y is e to 2x, x is 1, and the coordinate axes of the region is rotated about the y-axis, while the solid edge generated is represented by which of the following integrals. This might use the shell method since it's even underlying y-axis. So if you know the shell method, well, let's sketch the region up first. E to the 2x, how does that look? Looks like this, right? X is 1 is somewhere out here. This is the line and the coordinate axes. So this would be our region, okay? We're rotating about the y-axis, so yeah, we probably want to use the shell method because if we draw a representative radius, it would be up to like this point. It would be like this. So it would just be a length of 1, but over here it would be 1 minus this curve, okay? So let's do it the shell method. Okay. So we take a cross-section parallel instead. Instead of perpendicular, parallel to the axis of rotation. Okay. So remember, this is r, this is h, is 2 pi integral of rh dx. Okay. So it'll be 2 pi integral, wherever you draw your representative h, I forget the exact term for shell method, but wherever you draw your h, this r is the length of x, okay? And this h is just e to 2x dx, okay? We evaluate it from 0 to 1, okay? And that is A. Oh, 57% of people got this right. So I guess they learned shell method this year, okay? That's how we do this. F of x is x over x plus 1. Then the inverse function is given by, which one? Let me prepare my scratch paper. Inverse function, we can switch the y and the x. So y is x over x plus 1. We can say x is y over y plus 1. So now we solve for y. We can, let's just multiply both sides by y plus 1. So xy plus x is equal to y. Then let's move this xy to the other side. So x is equal to y minus xy. X is, let's factor out a y, 1 minus x. So then y is equal to x over 1 minus x. That's your f inverse of x. That looks like A. Sorry, C. I just flipped. I got the right answer, picked the wrong answer. Okay, so looks like C. Is that correct? Yes. Oh, only half the people got this right. 50%. Interesting. Okay. Which of the following does not have a period of pi? Okay. Let's just go with the sign first. Signs first. Sine x, we know, has a period of 2 pi. Okay? Sine x has a period of 2 pi. So when we absolute value the sine, remember sine looks like this, right? The absolute value, it would flip over here. So essentially the period will be pi. So we can eliminate that. Sine squared, it's similar concept because it'll flip to, since squared will make it always positive. So we can eliminate that as well. Okay, how about sine of half x? Remember the period is, if it's sine of omega x, the period is 2 pi over omega. So 2 pi over half, that's equal to 4 pi. So it looks like it's A, but let's continue. How about tangent x? Remember how that looks? There's asymptotes between negative pi over 2 and pi over 2, and then actually odd intervals of that. So that means that there is, the period is pi, so that's fine. When we square this, same thing, okay? So 32 is A. Okay, only 46% of people got that right. All right, absolute max of this guy on the closed interval -2, 4 occurs when? Okay, absolute max. Let's first find if there are any relative maximin. That is the first derivative test. So let's do find f prime. That's 3x squared minus 6x. We set that equal to 0 to find our critical points. You can factor out a 3x. So our critical points are x is 0 and x is 2. Okay. First derivative test. We plug in some huge negative number. This would be negative. This would be negative. Two negatives make a positive. We plug in a number between 0 and 2, like 1. This would be positive. This would be negative. So the sign is negative. We plug in a huge positive number. This would be positive. This would be positive. This would be positive, okay? So we know that there is a relative max at x is 0, okay? So we need to check f of -2, f of 0, and f of 4, okay? So, and we pick which one's the biggest. That's it. So f of -2, that would be what? We plug in -2 here. That would be -8 minus 3 times 4 plus 12, which is, sounds like it's, did I do that right? -8. Okay. F of 0 would be 12. That's easy. F of 4 would be 4 cubed is 64 minus 3 times 16 plus 12, which is what? This would be 76 minus, that would be 48. Okay. And this is what? 28. Okay. So this is clearly the biggest of the three. So f of 4 should be the absolute max. So it's at x is 4. 33a, yes. Only 48% of the people got that right. The next most popular answer was D, 33%. D is 0, so they picked the relative max, but it's not the absolute max, as you can see here. Okay. So whenever there's an absolute max min problem, you have to check the endpoints, okay? And it makes sense because, well, here we know that since this is a relative max, everything below that must be spot because it's increasing all the way to this max. Then it decreases, and then it starts increasing again, and it actually increases continuously, right, to infinity probably, because these are our only critical points, right? So f is always increasing after 2. So we had to check if f of 4 was bigger than this relative max, and it was, because as I said, f will keep increasing. Okay. Area of the shaded region in the figure above is represented by which of the following integrals? Well, if it's they are respect to x, so it's just upper curve minus lower curve. Upper curve is f of x, lower curve is g of x. So f minus g from A to C. 34 is D. How did only half the people get this right? What was the second most popular answer? 15% picked A. So it's not absolute value because, well, when you subtract them, then already all the negatives would cancel out. So anyway, this one's easy. Upper curve minus lower curve. So from A to C. All right. Moving on. This is a strange problem. For cosine of x plus pi over 3 is which of the following? So there might be a trig identity that you could use. I can't remember the identity off the top of my head for cosine of a plus b, what that is. So let's do what else we can do. We can just start plugging in numbers. Okay, so for example, when x is 0, I'll give you right over here, when x is 0, we should expect what? 4 times cosine of pi over 3, which is, let's say the output is y is equal to 2. So when x is 0, y should equal to 2. So let's start plugging in. When x is 0 here, that will be 4 plus 2, that's 6. Cross that out. Okay? When x is 0, this would go away. Then this would be cosine of 0, which is 1, right? So it's 2 root 3, which is not equal to 2. Okay. Then we continue. This would go away. Cosine of 0 is 1 again. So this would be 2, so we can keep that. This would go away. Same thing. Cosine of 0 is 1, so 2 times 1 is 2. We can keep that. How about here? This will go away. This is the same problem as this one. It'll be 2 root 3, which is not 2. Okay, so we eliminated 3 of the choices already. This is very good. So which one is it now? Can we plug in another point? For example, when x is... What's another easy point? When x is... I'm trying to make these 0. So when like x is pi, what is y equal to? Y is 4 cosine of pi plus pi over 3. That is 4 pi over 3. So that should be negative 2. So if that would still work here. Okay, so that won't help. Okay, so what's another technique that we can do? What happens if we differentiate? Would that help us in any of this? If we differentiate this, this would be minus 4 sine of x plus pi over 3. Okay, so y prime, let's say, is minus 4 sine x plus pi over 3. So what's the derivative of this guy? That would be minus 2 sine x minus 2 root 3 cosine x. Derivative of this guy would be minus 2 sine x plus 2 root 3 cosine x. So what's y prime of 0? Okay, that would be minus 4 times sine of pi over 3, that's root 3 over 2. Okay, let's just keep it in that form. When y is 0 in these, what do we get? We get, actually let's simplify. So minus 2 root 3. So when x is 0 in here, we get minus 2 root 3. So the answer should be B, because when we plug in 0 here, it's positive 2 root 3. So, okay, so we didn't even have to use a trig identity. Of course, if you know it, it will probably be faster, but even without it, I was able to solve that it was B. And only 25% of people got this right. Actually, majority of people omitted this question. Maybe it's because back then, I'm not sure what AP exam is like now. Maybe because I know for the SAT, if you picked the wrong answer, you get penalized. But if you skip, you don't get penalized. So maybe back then people didn't want to guess the wrong answer, so they omitted it. Okay, but this is one technique to do it. As you can see, I still got it the right answer without knowing the trig identity, if it even helps. I don't even know. Okay, what is the average value of y for the part of the curve y is 3x minus x squared, which is in the first quadrant? Okay. How does this graph look? We can factor x. Okay. So we know that the zeros are x is 0 and 3. Okay. So what average for the part of the curve which is in the first quadrant? Okay, so the zeros are 0 and 3. We know that it opens downward. Okay, so we can even plug in points between 1 and 2. That's totally fine too. That's 3 minus 1, which is 2. When x is 1. How about when x is 2? That's 6 minus 4, which is 2 again. So likely it looks something like this, right? And then they're interested in the average value of here. Okay? So it's just 1 over 3 minus 0, because those are the limits, right? Where this parabola is in the first quadrant. Integral from 0 to 3, 3x minus x squared dx. So this is 1/3. Integral from 0 to 3, 3x minus x squared dx. Okay, I just simplified the front portion. This is just power rule. It'll be 3 over 2 x squared minus 1/3 x cubed. Value from 0 to 3, which is 1/3 times 3/2 times 9 minus 1/3 times 27, which is equal to 1/3 times 27 over 2 minus 27 over 3. Okay, which is 9 over 2 minus 9 over 3. So 4.5 minus 3, which is 1.5. Yes, 60% of the people got this right. F of x is e to x sine x, then the number of zeros of f on the closed interval 0 to 2 pi is what? Okay, so e to the x is never 0. So only the sine x can make f equal to 0. Okay, between 0 and 2 pi, when is the sine 0? That is when it's 0, pi, and 2 pi. So that should be 3, since it's inclusive, 37d, yes. Only 45% of people got this right. The next majority picked C. Okay, so you gotta be careful about the endpoints, maybe that's why. So 0, pi, and 2 pi. Okay, here. X is greater than 0, integral of 1 over x, integral from 1 to x du over u dx is what? Okay, so let's do the inside first. Let me do it here maybe. Okay, integral from 1 to x du over u. That's just ln of u evaluate from 1 to x, which is ln of x, because minus ln 1 is 0. So now we just integrate this okay. Not true. This is this guy. So this guy here is ln x. So we need to integrate ln x over x dx. This is much easier. Okay. This one is doable, but it's integration by parts. This one is much easier because we can let u be ln of x. Du would be 1 over x dx. So it becomes literally just u du. So this is just half u squared plus c, which is half ln x squared plus c. Okay, so 38 should be E. Only 47% of people got that right, so I'll show this one more time. Okay. We first solve the inside, which is just ln x, and then we just plug that back into here, so that's here. And this, we just made a substitution. Okay. This one, integral from 1 to 10, f of x dx is 4. Integral from 10 to 3, f of x dx is 7. Integral from 1 to 3, f of x dx is what? This is simple properties of integrals. If we have integral from 1 to 10, f of x dx, we can break it out as integral from 1 to 3 plus integral from 3 to 10. You can think of integral as area, so you can first find the area from 1 to 3 and add it to the area of 3 to 10. Okay? And then they give us that, well, we want this one. Okay? So integral from 1 to 3, f of x dx would be integral from 1 to 10, f of x dx, minus integral from 3 to 10, f of x dx, okay? They give us the integral from 10 to 3. We can flip the limits and add a negative sign, or we can flip the limits here and add a negative sign. So when we flip the limits 10 to 3, we add a negative sign. There's already a negative here, so it becomes a positive. So integral from 1 to 10, they give us as 4. Integral from 10 to 3, they give us as 7. So that's 11. 39E. Oh, interesting. Only 34% of people got this right. This is simple properties of integrals, okay? Let's move on. Five more problems. Actually, let me do the last 5 problems in a separate video. So we're almost at 30 minutes already, okay? So please give this video a like if you found it helpful. And please subscribe to get notified for part 3.